Good. Okay. So let's go ahead and take a look. So here are the problems from Cournot, and I'll just read the first one. So consider a Cournot duopoly. The firm states an inverse demand function. So we're given the inverse demand function, and then we have a marginal cost function for each of the firms. So basically, we're gonna have a similar thing in like what we're gonna figure out. We're gonna say, well, okay, when they're behaving like duopolists, how much do they each produce? How much does the industry produce? And what sort of prices emerge? And is there a welfare loss? Is there a loss of consumer producer surplus as compared to competition? Remember, we're always doing all of our comparisons with respect to the competitive equilibrium when it comes to analyzing the impacts on consumers and producers, and any additional tax revenues that would be generated or anything like that, but to calculate those net social benefits. Okay. So, all right. I'll share the other. Okay. And oh, okay. Hold on just a second. Okay. So this is where we were when we left off last time. And let me see. And I'll stretch it out a little bit. But we have a couple of steps that we want to employ. This was the best reaction function, or the best response function, and sometimes you call it the reaction function, for just firm one. And remember the left-hand side of this, and I'll will remind you how we get there. So this is the marginal revenue of firm one, and on the left-hand side, and on the right-hand side is the marginal cost of firm one. So what we know is that marginal revenue equals marginal cost will give us a set of solutions, a setup, right? So we can find the profit maximizing quantity for, in this case, firm one, right? For some entity. The only difference is, remember that the marginal revenue that's on the left-hand side, it's this kind of interesting way of thinking about marginal revenue. It's the residual demand, and we're taking the marginal revenue with respect to the residual demand. So that's the really different thing. Before, right, we just had one market. It was the monopolist, and we took the monopolist's marginal revenue based on the whole market's demand function. It wasn't personal to that monopolist, because if it was another monopolist, they would have had the same marginal revenue. But here it's more individualized, right? And just like every firm has its own marginal cost, now they all have their own marginal revenue based on this formulation of demand for the residual demand. And if we think about competitive firms, right? Well, we know there that marginal revenue is based on the market price of the good. So we end up with marginal revenue equal to marginal cost, which is really, since marginal revenue is the price, remember, because they're price takers, so every unit they sell is going to be sold just at the market price. Then we also have this same equation. You know, competitive firms are going to maximize their profits by setting marginal revenue equal to marginal cost, but they all face the same marginal revenue, even though they might have different marginal costs. So really what's going on in these different models is marginal revenue is popping up as being different because of something to do with what economists would call market structure, right? You have one firm, you have many firms, you have two firms. In this case, this is duopoly. And are the firms cooperating for some reason or not? So just to be clear, right, this is the best response function for firm one. And we can, if we're careful, and you have to do it at this stage. If you do it at a different stage, right, then you'll see what I mean by stage. We formulated the best response functions this way, and now we have the marginal revenue is equal to marginal cost for firm one. But, right, we also need a best response function for firm two, right? And so now it's going to be MC2. But we're lucky in that we've gotten this far, right? And what's going to be different is now, right? So none of the demand parameters are going to be different. There's still going to be your A and your B. That's from demand. It didn't have anything to do with the residual demand. Remember, the residual demand came in when we said, oh, we've got to change Q to Q1 plus Q2, and then we've got to work with that equation at that point in time, assuming if I'm firm one, right, the Nash assumption is that I'm going to choose an action based on the assumption that the other player has already chosen their action, right? So player one or firm one is going to assume the quantity from firm two is held constant, and that's what gives them the residual demand. Because then they can behave like a monopolist with respect to the rest of the market. So, or the amount of market that's left over to them. So if you'll see, what I'm doing is I'm just changing these so that they reflect the parameters of firm two, right? And I could go ahead and go through all the math and algebra I did before, but I know, right, that this is where I'm going to end up. So why would make my life more complicated? And so if you see people do this, when they're solving problems, particularly this comes up in this stage of this analysis of industrial organization, and and where you're applying game theory because you have lots of different firms and they'll sometimes be doing different things, and you'll see that um, authors and other people will do stuff like this, and then they'll say this because they didn't actually derive it. They'll say by symmetry, and now you have to be careful because when you begin to employ this, you just have to really make sure that things are symmetric, meaning it really would be the same because you'll see a lot of people when they're first starting out doing this kind of stuff, it's almost like, well, it's a shortcut to not to have to do any work. I just can say, well, like I already did the work, right? But it only works if the firms are in the same situation. So, so just to make sure that you really know that that's the case. Okay, so we have to formulate the reaction function for firm one and the reaction function for firm two. So, so this is the first stage, right? And then I told you guys the next part is to say, okay, the reaction function itself, and I'll say RF, right? What that means, and it looks like this. It's Q1 is equal to some function of Q2's output. And this is the point where, remember, we had the little wings or whatever on Q2, so we would recognize that it was a constant. But at this point in time, we can say, oh, well, that constant is arbitrary and just use it as Q2. So the reaction function for firm one would look like that. And likewise, I'm just going to copy this really quickly and write it down here. And reaction function for firm 2, Q2, and Q1. Okay, so what I want you guys to do then is I'm going to go ahead and share the Ignithium screen. And you guys go ahead and work on formulating the reaction function for firm one and firm two in this first problem. And then I'll get back to you guys in just a few minutes. Does anybody have a question for me really quickly? Okay.
Professor, can we see the reaction functions one more time?
Well, okay. You're gonna kind of trip me up because I gotta switch the share, but I'll try. You guys gotta take a picture of it or something with your phones, right?
Yeah, I'll take a picture of it.
Yeah. Okay. So let's. Oh, see, now it's like it doesn't want to give me the right whiteboard.
All right, it's okay.
I knew that was gonna happen. It's there someplace, and it's. I hate when it does this. So I'm gonna stop sharing. Let me try again. I want my whiteboard back. There it is. Take a picture of it.
Got it. Thank you.
Okay, and now I'll share the other one. Okay, and okay, so I'll give you guys about 5 minutes to do that. Okay. How is everybody doing? Does anybody have any questions? Okay. So we should be at a place now where we should have some at least good attempts at reaction functions for firm 1 and firm 2. So who has an attempt they would like to share? Nobody? Okay. Well, why don't, oh, Greg has his hand up. Thank you,
I'm
Greg.
not too confident in my answer, but I'll give it a shot.
Well, you know, has that ever stopped you before?
No, never. I've been wrong all the time.
You know, come on. So okay, so now let's do this in the chat too, so I can see what you're saying and other people can too. So I guess, so my first question for you would be, we'll kind of take this step by step, right? And let me do, okay, I think that's gonna be fine. So what was your first step?
My first step was to get marginal revenue. So I
Yeah,
doubled the.
well, actually, you know, your first, and I'm just gonna help you out here. Your first step
Sure.
should be to formulate the residual demand for firm 1.
Okay.
Okay. So you remember how to do that? So
I'm looking back in my notes. Oh, with Q1 and Q2.
yeah. So it should look like that.
Okay.
See, because this is one of the points of, you know, Cournot, is that, you know, the market is not your own, right?
Mhm.
And I'm, you know, speaking in terms of personal metaphor, right? Your own, but it's not the firm's own. It's not, that whole market's not his to have. He can't compete for it. He's got to share it, right? So that's different in competition. In competition, that was kind of like bare knuckle fighting, right? Like, it's not that you couldn't have the whole market. It's just that everybody else was competing for it, and you only ended up with a little slice. But here, it's different, right? All of that demand out there doesn't belong to any of the firms wholly. It's not possible, right, for them. I mean, that's our setup, is like they can't take it all. So they have to share it. And so we want to focus in on that part that's just theirs. So we have to do this residual demand. So did you formulate your residual demand? And you're like, I'm working on it. Greg?
Sorry, I muted myself in case there was a thing, like a reverb.
Okay.
So I got 351 minus 6Q1 minus 6Q2.
Yeah, and you'll notice in mine, and this is what I was trying to tell you guys when I did it last time, and I don't know. I uploaded the video from last time, I think. But if you guys watch it again, that's why I was doing the little wings on the Q2. So here I have Q2 bar.
Yeah.
And that's to designate that Q2 is a constant from the perspective of firm one. So yeah, and this is kind of interesting to me because just mathematically, I can go 351 minus 6Q2 bar. I'm going to go ahead and put it in little square brackets, minus 6Q1. And I'm going to call this PB1 with a tilde over it. But so check that out, right? So I just moved it over, and I don't know if you can see, but the 6Q2 bar there, right? So this whole bracketed term is just like the constant in a linear function or the vertical intercept, right? And then notice that the slope of the linear demand function is still the same as it was for the original one all the way up here. So what's happening is that you have some original demand function, and if I could really figure out how this darned thing works, I'll see it, like it doesn't always give me the tools. Hide floating controls. Hide video panel. Okay, I just hid my floating controls, which I think is not what I really wanted to do. Anyway, now I want my floating controls back. Anyway, I would draw you guys a little picture, and I'll do it out here on my notebook, right? So here's, you guys know where the original demand function is. Okay, 351, like that. And now it's just being shifted down. Now we don't know what 6Q2 bar is, right? So this is, okay, Greg, you see my little illustration?
Yes.
You see, so like we have the original demand function, and then like what this equation says is you're just shifting demand down for firm one. His residual demand is going to be identical. It's just going to be shifted down by the amount of demand that's taken by firm two, right?
Yeah, that makes sense.
Now, what is you know, I guess cool about that is that, remember I said that firm one will behave like a monopolist with respect to his residual demand. So you should be able to move from this residual demand equation right away to the residual marginal revenue. And since I have you on the line, by doing what?
Doubling the slope. So the 6Q1 part would be negative 12Q1.
Yeah, that's it.
Yeah.
And, you know, again, if you want to be more technical about it, you can get the firm's total revenue using their residual marginal revenue, and you can take the derivative. So it would be the PBB1 tilde times Q1 is the total revenue for firm 1. And so anyway, I showed you guys this last time. You go back on the other video, but the Q1 is going to multiply all the terms, right, in PB. So there's my total revenue, right? So this Q1 times PB1 tilde, that's going to multiply all these terms in PB1 tilde, but it's only going to create a quadratic on the existing Q1. So then when you take the derivative, everything that's a constant is going to pop back out as a constant in marginal revenue, right? Because that's the derivative of the total revenue function with respect to Q1. And this one, because it's going to have the quadratic term, is going to be multiplied by 2. So, you know, for those of you that know calculus and you kind of want to go through the steps and say, okay, I know that marginal revenue is the derivative of total revenue with respect to the output of firm 1, you can do that. Everything is fine. But if you don't, then if you're not really comfortable with your calculus or you haven't really had it yet or something like that, you can just say, okay, I know that the marginal revenue for these linear functions is going to be just like Greg talked about. So again, I'm going to bracket the term that represents the intercept of the residual marginal revenue, the constant term, and then I'll just do what Greg did, minus 12 Q1. So that's what you have, right, Greg?
Yeah, that's what I got.
Okay. So, and then the next step is to do what?
Get basically the right side of that whole equation with marginal cost.
Yeah,
So,
set marginal revenue equal to marginal cost for firm 1.
Yeah.
Okay. Okay, so you want to tell me what you got?
Isn't it just 14Q? But and I have a question about like how to manipulate Q, I guess, in the marginal cost side of things.
Well,
'Cause-
you have to kind of, know what Ignithium's talking about here. When we see MC1 is equal to 14Q, that means the Q for just that business. That's our Q1, right? As opposed to like QB represents the total quantity at the market level in the market demand.
Okay, all right.
So
I
like
would,
maybe you were thinking, oh, well, I got to put in Q1 and Q2 here. But no, that wouldn't make sense because, now I will tell you, this is a interesting side note, right? So, and you'll be able to see clearly probably at the end of today, if not on Tuesday next week. But all of these like basic industrial organization models, all they do is, remember, we're always going to have the and I'll, I'm going to put little stars around it. Right. Okay. Can you see? I put wow with little stars around that.
Yeah, I can see that.
It's like bright and shiny. It's a beautiful thing, right? That marginal revenue equals the marginal cost. It's like tattoo worthy. I sometimes, recommend students get tattoos to help them remember, things that are important in econ. And like you could get like a I heart efficiency, something like that. That's pretty important. But it's always marginal revenue is equal to marginal cost. It identifies the profit maximizing quantity. And what happens in all these basic models is just the form of the marginal revenue changes, because the marginal cost is technology driven. Costs are technology driven. People have machines, right? And equipment, the materials, labor, whatever, but they're costs of production. And you remember combining labor and capital together to produce stuff, that's a production technology decision. So what's the optimal combination to minimize my costs? So that's not going to change whether that firm happens to find itself in a position where it could be a monopolist, or it could be it's a competitive firm, or it's in some other structure like the Cournot structure. So, same thing. But what happens is that revenue side of the equation changes. So you see the exact same thing. Okay, marginal revenue equals marginal cost for the firm. Marginal revenue equals marginal cost. The marginal revenue changes depending upon the industrial organizational structure of its industry. So yeah, so if you kind of get that, then you'll know what to look for. Okay, what's going on with the marginal revenue here, and then you'll see. But it is possible that the marginal costs of the firms can interact too. And when that happens, you have some sort of externality. What's happening is that for some reason, firm 2 is having an impact on the costs of firm 1. And sometimes there are stories to tell, and they're interesting for why that might happen. The basic sort of story is that there's some sort of technology that firm 2 is inventing, and firm 1 is, and I'm just going to use these terms to be transparent. It doesn't necessarily have to be that. They call it leakage, right? But basically, like, firm 1 is stealing the knowledge from firm 2 for how to produce its product at a lower cost. So the more that firm 2 produces, the more their technology and innovation grows, and the more firm 1's able to observe and to lower their costs. So you could have that kind of thing. But those are more sophisticated models and beyond the scope of this course. But just so you know, you'll always be hanging your analysis on the marginal revenue equals marginal cost. That won't ever change. It's just the stories about, you know, what marginal revenue looks like and what marginal costs look like change. But in this case, there's no reason for us to assume there's any sort of information spillover or leakage or other sort of externality between the two businesses in terms of their costs. So there we're safe. So what did you end up with then? Do you want to give us the answer?
The total that I got at the end was 351 minus 6Q2 bar.
Yeah.
Plus or equals 26Q1.
Right, and then your last step would be what? Because you want, remember our reaction function.
That's right. Okay, sorry. So I guess it'd be that whole left side divided by 26.
Yeah, and then you should end up with something like that. And notice I put Q1 and I put RF up here for reaction function. You got 351 divided by 26, and this is 6/26. I could have reduced it, I just didn't, you know, times Q2. And so what this tells us is that if Q2 produces however many units, and notice I took away the bar now, right? So tell me how many units Q2 is going to produce, and then I can tell you what's the optimal response. And by optimal, I mean the profit maximizing response in terms of output for Q1. You know, they produce 10, so I just, Q2 produces 10, and now I can see how many Q1 should produce, right?
Gotcha, thanks.
So, one other thing I guess I'll point out, and this is pretty common, is we often, and I've asked this on exams before, we often graph the reaction function. And okay. And what I want to pay attention to is the intercept of the reaction function. Because, so here I've got Q1 RF on the vertical axis and the amount that Q2 is producing on the horizontal axis, right? And notice this is if Q2 produces 0, then Q1 would produce that 351 divided by 26, right?
Yeah.
Well, this, right, if Q2 produces 0, then there's only one firm left in the market. So that would be the monopoly quantity of output, right? If all the market's left for firm 1, firm 1's going to behave like a monopolist. And that's the monopolist quantity of output. And then as firm 2 produces more, then firm 1's going to drop down from that monopoly output. And eventually, if firm 2 produces enough, then firm 1 won't produce anything. That's the horizontal intercept over here, right? And so graphing that reaction function can be very useful. But so I'll ask right now, does anybody have any questions? If you have a question, go ahead and raise your hand about what Greg and I just went through. Anybody? And if I don't see your hand because I can't see everybody at the same time on this display. But go ahead and just unmute yourself or type something in the chat, and let me see. So, Efren, how are you doing this morning?
I'm doing all right.
So you laughed? What did you laugh about?
Oh, I laughed at the marginal revenue equals marginal cost with the wow.
Oh yeah, right. No, or if you guys know this one, it's the whoa,
Yeah.
right? So my daughters are doing that stuff on TikTok all the time. So anyway, okay. So we did the reaction function for firm 1. Now you guys do the reaction function for firm 2, and I'll come back to you guys and ask for answers. And I could ask anybody. So get ready to type your answer in the chat. And remember, what you should be ready to type in the chat is something that has Q2 in terms of Q1. Be an equation like this. Okay. Any questions? Okay. So I'm going to type here, formulate the RF for firm 2. Okay. I'll let you guys get to work for a few minutes. Okay. So who has the answer? Okay. So I'll sing the song for you guys. If you don't know the answer, raise your hand. If you don't know the answer, raise your hand. If you really don't know it, and you need some help to show it, if you don't know the answer, raise your hand. Okay. So Robin, let's talk. You got your mic? Robin?
Oh, sorry, I was muted.
Okay.
Yes, I'm here.
Okay. So what's the issue?
I guess the issue is that so I wrote everything down and I have the equation from last time. I'm just not knowing where some of the numbers are coming from. So for example, like the 26, I'm not sure where that came from in the denominators.
Well, okay. So remember the golden rule,
Okay.
right? And there's little stars around it. You see? It's all special and pretty.
Yeah, I just put some
Shiny.
stars around mine too.
Yeah. Or maybe a tattoo. I mean, you know,
Yeah, maybe.
maybe. So, but what do you think should be different here?
Well, I mean, if they're equal, I'm not sure if, I mean,
Well, now look closely. Read with me. That says M, R, and what's that say?
that is a 1,
Yeah, equals.
MC1.
Okay, so now in this case, it should be M, because this is firm 1, right?
Yes, so it's gonna, for the next case, it's gonna be MR2 equals MC2.
Yes.
Okay.
So if you don't start with that, then you're not going to get anywhere.
Mm-hmm.
It's just not going to happen. So the first line should be MR2 is equal to MC2. Now, MC2 is given to us, right?
Yeah.
We have
17.
17Q2. Well, we don't know MR2. That was what we were spending all the time before,
Mm-hmm.
right? So, but we said that we were kind of lucky because, well, I mean, do you wanna, did you work on the MR2 part?
I was just kind of looking at the 26 the whole time. I didn't know where that came from, and that kind of caused all my confusion. And I didn't really, yeah, I did. To answer your question, no, I didn't solve for MR2.
Yeah. Well, just to remind you, right? So right there is the MR1.
Mm-hmm.
See there?
Yeah, I'm just trying
And
to see. Yeah.
you see the MR 351 minus 6 Q2 bar
Mm-hmm.
minus 12 Q1, right?
Yeah.
And then we take the MR1, right? And we set it equal to the MC1,
Okay.
right?
Okay, I see that now.
And then if you look, right, you have this Q1 here and a Q1 there, and it's 12 and it's 14
So that's 26.
minus 12. Yeah,
Okay, I see that now.
right. So over here, it's going to be different. There's not going to be a 26
Mm-hmm.
because now instead of having, before we had 14, now we're going to have 17 and it's going to be Q2.
Yeah.
So, but the MR2 is what you got to work on.
Yeah.
So, okay. So, thanks very much. We'll move on to the next customer. And I noticed that Noah, you had your hand up.
Yeah, I was stuck on the same thing that Robin was, but it's making sense now.
Okay. Okay. Did you make any progress with the MR2?
No, I was just trying to. I got lost on MR1, so when you explained that, I was able to like catch up on it. So, but now that I know that, I could probably figure out MR2.
Okay. Okay.
Yeah.
And what about you, John? I saw your hand up too. How you doing? John McKean? Are you there? No, I'm not hearing you. I don't know if you put something in chat or not. Oh, you don't have a mic. Okay, sure enough. So, who needs another minute? If you guys need another minute, raise your hand. I'm looking for hands. Okay, Robin, Noah. No. Okay, do you have a mic today, Ruben? Ruben?
Yes, I do.
Okay, so what about you? How are you doing?
Yeah, I get it.
Okay, so you wanna help us then? Finish up?
Well, yeah, I did the same thing for
Okay, nice.
that's what
I
I
see
got.
what, yeah, okay. So I see what you put it in the chat. That's awesome. And I'm assuming it's right, because it looks pretty good. But could you take us back, give us your MR2, just so we can see where you got your 29 from.
Yeah, that would be
Yeah, right. And oh well, hold on, wait a minute. I think you made a little mistake. Did you see it?
oh yeah.
Yeah. Are you gonna fix it? Are you typing? Yeah, right. And so Ruben, okay, and you set that equal to your MC2, and you want to write the MC2, which it's an
Yeah.
error, but anyway, right? And then, right, then you take the 12 over to the other side, and you get 29, and 29 Q2. You divide both sides by 29, and then you get the result. So you can see really the whole work here is in formulating the residual demand, and I'll just put for the residual demand, I'll put P R2. This is the residual demand for firms 2. It's going to be the 351 minus the 6. And remember, I'm just going to put, and in little wings, the Q1 to designate that it's a constant minus 6 Q2, like that, right? That's really all the work right there. And the only reason why it's really important to designate that Q1's playing the role of a constant here, and I'm pretty sure that you'll appreciate this, Ruben, is because if it wasn't, right, then potentially when we take the derivative with respect to Q2, Q1 might be a function of Q2 also. And so we might have to factor in that derivative if it wasn't a constant. If it's a constant, then we don't have to worry about it. So anyway, yeah, mathematically at this stage, that's important. So now I'll go ahead and we'll kind of like take this to the last stage, which is we had this reaction function graph, and mine's imperfect, but so notice I've drawn the reaction function. I put Q1 here and Q2 there for both of the firms. So this is Q2's reaction function. See, it's 351 divided by 29. If firm 2 was a monopolist, because their marginal costs are different, they would produce a different quantity of output than firm 1 if firm 1 was the monopolist. And then where these two equations intersect, this is the Nash equilibrium level of output. Okay. So we have the reaction function for firm 1, and we have the reaction function for firm 2, and so then we find the intersection for the for those two reaction functions, and that'll give me a Q2 NE and a Q1 NE, and that tells me that firm 1 will produce this quantity of output, firm 2 will produce that quantity of output, and then the industry quantity, obviously you'll add up the Nash equilibrium quantity for both of the firms. So, okay. So let's see what Ignatius says the Nash equilibrium quantity is for this industry, right? And just so you guys know, this is, you know, the next question is, what would be the equilibrium, Nash equilibrium price in the industry? Well, if you know this is the total quantity, you just plug it back into the original demand curve. You don't need to, you know, worry about the residual demand curve. So you just plug the 21.02 back into the original inverse demand curve here. I'm highlighting it. And then you can get the Nash equilibrium price. So what now we have the industry quantity, which is our question here, but we still have to you know, use the two reaction functions to find the quantities that, you know, we don't know for the 21.02. I mean, I would kind of imagine, because the marginal costs are pretty close, that they're going to be splitting the market almost evenly, right? So 14Q and 17Q, those are pretty close to one another. So I imagine we're going to get something like, you know, firm 1 that has the lower marginal cost would probably produce a little bit more. So they'll probably produce about 11 units, and firm 2 would probably produce about 10 units. So together they're going to produce the 21 units. 10 plus 11 is 21. But obviously, I don't really know till I go through the math and and find the Nash equilibrium output for each of them. So at this point in time, I'll ask, does anybody have any questions about what we've done so far? Because our next step is to go ahead and solve for the Nash equilibrium now that we have the reaction functions for both of the firms. Okay, questions? Okay, so I'll give you guys 5 minutes. Remember, you have the reaction functions for both firms, so you can have, here's Ruben's version of the reaction function for firm 2, and mine was Q1, or the one that Greg and I worked on earlier, 351 minus 6Q2 divided by 26. And actually, I guess I'll do it that way. And I don't know, as long as we all agree. Okay. Then we can go from there. Okay. So go ahead and those are 2 equations and 2 unknowns. It's just like all the other stuff that we've worked on before, like demand and supply, or the consumer's optimization problem, where we had the budget constraint and the tangency condition, 2 equations, and we had to find the quantities of the 2 goods, the X1 and the X2. So here we have Q1 and Q2. We don't know them, but we've got 2 equations, and we can solve for it. So go ahead and solve for Q1 NE and Q2 NE. Okay. Any questions? Okay, I'll go ahead and give you guys a few minutes to do that then. So,
Is it because the consumer is going to decide to go with the firm that has the lowest price?
well, yeah, that's part of it. But I don't know if you can add more to that.
Yeah, I'm trying to. That's, I think my brain is like trying to get there, and I'm still like, shoot.
Yeah. So, okay, so we have somebody. So Jen, I guess I don't really understand your comment. I don't know if you have a mic or not. No mic. Yeah. So, because well, marginal revenue is equal to price and competition. That's true. But we're talking about, so the strategic setting here is that firms are competing on the basis of price instead of setting quantities. So maybe I don't know if that's enough of a hint. So, well, nah, I wouldn't go quite that far. I wouldn't, because the goal is still to maximize profits. Okay. So really what we're talking about is that price is their strategic variable. So I'm responding to Jin Kao's comment. If a firm has a price goal, then the marginal revenue of the firm is the price. Then no, they're still trying to maximize profits. They only have one objective, but their space of interaction, their strategic variable, is to vary their price, not their quantity. Well, I'll sum it up. Unless anybody else has, I'll give you one more shot. Okay, anybody else have an idea? Per unit cost? No. So I'm asking you guys to think about the way that price competition functions. So if I'm firm 1 and I set my price here, then what does firm 2 do to compete with me? I know it's foggy in San Francisco, but I think you could do this one. Yeah. So Aubrey, are you there?
Yeah, I'm here.
So what do you think, right? If I set my price here, what do you do if you're competing with me?
I would set my price lower.
Yeah, just a little bit lower, right? And
Yeah,
then
just
all the customers would come to you. But then if I'm competing with you, I'm gonna come back and set my price a little bit lower than you, right?
Yeah.
And we'll keep undercutting each other until we hit our marginal costs. And remember, our marginal costs includes all of our opportunity costs. So we're still making a normal rate of return, right? And so this price competition causes us to undercut each other, right? And so it's because of the way that price competition works that we, just blow right through to setting price equal to marginal cost. Because at that point in time, I can't undercut you, you can't undercut me. We're just both. And if our marginal costs are the same, then that's going to be the marginal cost for the whole industry. So I think that's a really interesting result of the Bertrand model. And you can, tease it out mathematically with reaction functions and things like that. But the point is so intuitive. The one thing I think I would ask, and this is just my final question, and I don't know if you have an answer, Aubrey. So where do we tend to see price competition?
like, are you asking like what?
Yeah,
type of
like what type
product?
of businesses do price competition?
Like grocery stores?
Yeah, so I think it happens a lot in retail, right?
Yeah.
Like direct to consumer stuff. And I guess the question would be like, well, why do we see price competition there as opposed to, big industrial firms? And do you have an idea of why that might be the case?
Well, I think it's because those companies like grocery stores, like any retail store is like they're marketing towards the general public in comparison to like.
Yeah, I think that's part of it, but there's something else too, which may be a little bit subtle. So if you think about it, let's say Target versus Walmart or whatever. If I go into Target, what am I going to buy? I'm going to buy, limited to groceries. Like, what am I going to? I'm going to go buy like a bag of Lay's potato chips, right? And if I go into Walmart, I'm going to buy a bag of Lay's potato chips. It's the exact same product, right? And guess what? Target didn't make it and Walmart didn't make it. So their costs are the wholesale cost they get it from. So the product, really what they're selling is this retail service, right? But they're not manufacturing the products. They're just reselling them. So they're competing for that markup. So the only reason why I bring that up is because when you guys think about these models and which ones would apply, right? Then remember that, if you're talking about things where they're very what I would call like, and this may be a bad way of talking about it, but I'm going to use it anyway because nothing else comes to mind. But there's a super short supply chain for what's actually being delivered to the consumer. And I'm talking about retail being a short supply chain in the sense that you buy the product at the wholesale level and turn it around immediately to the consumer. Then you tend to see a lot of price competition because the costs are relatively uniform. And like Ruben pointed out, he said a homogeneous product. Yeah, I mean, in the sense that laser, it's the same thing. The only thing that the real product we're talking about is the retail service component. And that's where there's a little bit of differentiation. But if you're talking about big industrial things like airplanes or wheat or something like that, they have long supply chains, right? It takes them years to design and build an aircraft. Well, at the front end of that whole process, Boeing has to decide, how many airplanes do I want to roll off the assembly line? You know, and they have to build their factory for that. Well, that's a quantity setting game, right? I got to build this factory to push out 1,000 aircraft a year. So I better have that in mind, what quantity I'm going to be pushing into the market at the end. Boeing can't compete on the basis of price in the way that Walmart can. So, and the final issue is that when we think about these models and which ones to apply, then, you know, we have to think about, okay, is this more of a price competition or a quantity setting competition? Think about the type of industry involved, and you know, the length of the supply chains and those sorts of things. But the really cool thing about Bertrand is that there is no deadweight loss, because if you end up with the competitive outcome right away, you don't have to worry about, oh, there are only a few firms in this industry. You know, as long as they're not coordinating and behaving like a cartel, immediately, boom, you get a competitive outcome. So you could have 3 or 4, you know, big retailers, and that's really all you need to get a competitive outcome if they're competing on the basis of price. But if you only have 3 or 4 oil refiners, which are competing on the basis of how much throughput they can push into the market, well, then you got to worry about Cournot, and you got to worry about that the quantity is going to be significantly less than the competitive outcome, because then you'll end up generating deadweight losses. And hopefully you guys can see, I could kind of show a deadweight loss triangle here if I took this line all the way up. That's all I have to say. Do you guys have any questions for me?